Hi, today we will talk about three-sum question. They will provide integer array nums, and we have to return all the triplets such that when we sum them, we get the answer equal to 0. Let's get with some example. Let's suppose this is num array, and you have to get triplet 3 numbers. When you add them, you get the answer 0, and you have to find all of them. We will go and discuss about this question and also about that how actually you will get this question and what are the questions you have to raise, because in interview no one is going to ask all the question, like he's not going to give all the description, and we will talk about what questions, what should come in our mind and what points we have to clear prior making any code. Let's see. All right, so first thing we will talk about the question when they're asking that we will provide you some array, and that array will contain some int, and we have to find triplet whose sum is equal to 0. So sum num1 plus num2 plus num3, and that sum equal to 0. The first thing we should know that everyone won't tell all the question that as it was written, and you can see examples will be there and all descriptions, all corner cases has been mentioned. So no one give you any question like this. No one will give you like that. They will just tell you we have an array and you have to find all numbers whose triplets whose number sum is equal to 0. Now we have to raise some questions. It's our job that we have to raise some questions. And how we can raise some questions, quality questions. So to raise some quality question will for sure give better understanding of the question, and you can come up with a good solution. So you can come up with some question if you know something that, okay, your brain is calculating something, it is calculating, let's suppose, some type of solution, like you're thinking type 1, type 2, you're thinking, okay, I can solve it like this, or type 3. And then out of that, there will pop up some question in your mind. And then you will think that, okay, this type of question falls under not T1, not T2, but might be it falls under T3 and T4 category. And then according to that, you will raise some quality questions. This is how we have to work. So what question first? To raise some question, you have to first come up with some example. Okay, you will say, okay, let's suppose if I will take -1, -1, 0, 1, 2, suppose. Always go, the first step, that always go with an easy basic example, right? So that you can come up with some better question, and then you can later go with some corner cases and some detailed questions, right? In the easy basic example, what you will see that, okay, I consider 3 triplets whose sum is equal to 0. So what I will do, I will just pick -1, -1, and I think 2. Okay, that's the solution, because how I was working from solution to my mind is going for some questions. So I'm thinking, okay, this -1, -1, and 2 is some solution, and you use it as an example, right? And if there comes something that you have to find, okay, it is some questionnaire, might be I have to raise this question, so that time you have to ask the question. So what I think here, I was thinking, I just pick some random example, which is here, and I start thinking, Okay, minus 1, I was thinking minus 1, and 2 will be one solution. And I can also think minus 1, 0, and 1 is another solution. Their sum is also equal to 0. So we have to ask some question. Do the first question, let's suppose if I can ask, I will say that, okay, this minus 1 is also there. Do we consider another solution similar like that, considering this minus 1? Maybe he will say, as per the question in the Leetcode, they will say, no, it should be a set. It must not contain duplicate triplets. So no, it should not be duplicate. No duplicate. Right? Now the second question I can come across is, okay, is that array is sorted? So maybe he will say no, as it is in the Leetcode. Now, when we come across this question, there is some theory, there is already some solution in our mind, what we were trying, that okay, I can use, let's suppose, two-pointer coding pattern. That's why I raised such questions. Now how I was actually shadowing it, how I was considering that this is two-pointer coding pattern. Now think about that. Let's suppose, as we have already solved some question when we say find two sum, so 1, 2, 3, 4. For two sum, let's suppose someone is asking, okay, make it 5, and they were expecting two sum equal to 7. So find n1 plus n2 whose sum is equal to 7. So what we did, we said, okay, we will go with two-pointer approach. There will be pointer number 1 and there will be pointer 2, and we will keep on moving. Either we will move this pointer here or we will move that pointer here, with considering the condition. This is how we can solve the question in two-pointer. Now the three triplet, in that case, what all triplets we have to find. So what we can do, let's suppose, considering the same example, minus 1, 0, and 1 and 2, what we can think of it is, okay, we will apply two-pointer coding pattern, but we will put our one number, let's suppose this one, as a standard, and then like we will consider, okay, right now we have one number, this minus 1, and we will remain here. So we can consider this number here is the first number. Okay, let me remove this, and I pick the next number as a left and the next last number as a right. Now these are three numbers. We will say try to find them. So we will say pick minus 1 from here, minus 1 from here, minus 1 from here, and 2 from here. And the sum will be minus 1, and plus 2. So we will get equal to 0. So we found our solution. We will add it into some list. And then what the next step we will do, we will say, okay, this part is done, but we can find some other solution also. If we say, okay, this is done, we can still find some other solution by moving this to the next one, the left pointer to the next, right pointer to the next. So we found a solution with 0 index, 1 index, and the last index. What we will do, we will move these two pointers further. So left will go one step further and right will go one step backward. Now the next step will be, we will point it here. In that case, that pointer will go here, and we will use second pointer, which will also, the right pointer will also move forward, and that will go here, right? In that case, and this pointer will remain here. We will again say, get the number. That time we get minus 1 from here. It says 0. That pointer say 1. So minus 1, plus 0 plus 1 is equal to 0. So in that case, we also found some solution, and we can also save it in our list. The next step, what we will do, we will say move this pointer to the next step, because after that left and right will cross each other. So this left will move, should be less than equal to, might be only less than equal to, less than right. That will be the condition. And the next, what we will do, we will move this pointer further. We will move this pointer here. Now in that case, this left pointer will also go next. In that case, we will start this left pointer from this point, and right pointer will again start from the end, and we will again keep on doing the same step. So let me rephrase what we will do. We will just keep on moving this to the next step here, and then we will again do the 2-pointer approach with the remaining array. So this is what we will do. In that case, we will keep on shifting that number, which will be the first one, and we will apply 2-pointer coding pattern here and here. In the next step, we will skip that. We don't use this because we have already came up with the solution. And the next one, we will put that pointer here, and left pointer will remain here. It will go for the next one, and the right pointer will go for again from the last. And also for the last picture, might be that will be gone, that is gone, and we will come here with this number, and that will be the left one, that will be the right one, and again we will keep on doing, and we can find triplet, and we can keep on saving at each iteration our result, right? And that will be a set. This is how we will go and apply our 2-pointer coding pattern. Now let's see, we can code. First we will solve this in a Heap approach, and after that we will convert it into a functional code so that both worlds can get the benefit. All right, so now we can start looking at the code. So we already know that we have to solve this question using 2-pointer coding pattern. Pattern that we have to use is 2-pointer coding pattern, and for this we need some nums array. So there is a int array is already there, or list or vector, and we have, it is not sorted, but we have to sort it. We have to sort it because we were looking at the 2-pointer, which will work on sorted array, because in case when we find the sum, we have to know that either we have to move the left pointer or the right pointer when we find less than or greater than the sum expected, which is 0 in this case. And now there is some constraint is already there when they are saying find sum equal to 0 for triplet. So n1 plus n2 plus n3. So we have all those mindset, and now we are going to solve this question. So first we will go with the Heap approach. What that approach will be, first we will think that simply we have to take the left, which is 0. We will take the right index, which will be nums.length minus 1. And we will get some array, which should be answer, some set, because we have to go with some unique triplet. We should not repeat. So we will use some set. Well, now we get these 2-pointer, and now we will come to sort our array to satisfy this condition. So we will sort it here, sort array. And for sorting, we can use sorting.quick sort, which will be an in-place sort from Scala, and we can provide the nums here. Now what we will do, now we will apply the same concept what we were talking about, that there will be a green pointer which will remain at the very start of the index, and left will start from the next index and right will be always from the end of the array. So we will go with some, we will loop it, we will say n and index we need by, we say nums.zip with index, and zip with index we already told about that. It will zip index with the number of each in each array, and we will return a tuple. So the left pointer, as we already talked about, it should start from next, from this. So index is a green pointer which I was mentioning before, and the left will start from the next pointer, and right will always start from nums.length minus 1 from the end. Now we will go inside and keep the condition that we will keep on looping and left and right should not cross each other. And now we will say we have all those number, find the sum. So n, which is here, we add like the number at the first index, at the green index. So num plus nums at left and plus nums at right. So we get the sum. At that point we will say, okay, if sum is equal to 0, have we found our target? If we did that, we will simply say answer plus add it with the list of n nums left and nums right. In the next line, what we will say, okay, now we have found the solution. So we will move left one step ahead and right will move one step back. Correct? In the else part, if it is not equal to 0, so we will say else if sum is greater than 0, we found some bigger number when we sum all those three. In that case, we will say right, you should go back one step. In the else part, we will say make it like, I think this. Okay, in the else part, we will say left, move one step further. And finally, we will say answer.toList, because this is a set. Answer is a set, and we keep on adding list in it. So it will be unique. If you found duplicate, still it will not entertain that. Now when we run this code, it will work properly, but this is an OOP approach. Now I will tell you that how I can convert this into in a functional way, how we can write the same code. The first thing we have to find that what elements are actually changing. So when we are going to write functional code. So we have to first thing, we have to look at, let me make it a block of code here, and I will say, the first thing we have to say, what is changing? What is mutable? So we have to make that immutable. And we have to, if there is some loop, better convert it into recursion. And further, we can use some higher order function to make the code more clean, robust. So, okay, now in that case, what I will do, I can see left pointer is changing, right is changing, answer is changing, but in FP, I won't use mutable. I will use now immutable. And for this, the first step I will say sorting.quicksort, and I will sort it. For sure that this is what we have to do. We have to sort our array. Sorry, not an answer, but nums. And second, what we will do, we will get this nums, we will zip with index, and we will say fold left, or I have already told you that how to use that. So fold left, and I will say this is what I am going to get. This is what I have to populate in each iteration if I will find some answers. So I have to add it into this set. So that set will be list of int. And now I can go further here. For the case, I will say this is our answer, the same as I was using here. And in this step, zip with index is actually making this n, and that is an index. Now I will go further, and here I will just use the same recursion, the same code, because this is the loop, what is actually iterating. So we already come here by using this zip and everything, zip with index and fold left. And now we have this map, we have this index and number and answer. And this time we can just go with some go or some helper function that will say, I will provide you I will provide you n, the same I was using here. And I will give you my index, which is left. So I will say index plus 1. And I will say take this right, which is num's length minus 1. And that's our answer. So I'm providing this function, our index like the number, which is at green index, the first one, which keep on staying there unless two pointer get complete for that iteration, and then it move forward. And then I provide this left, and this is right, and this is our answer, which like this set, which has to be populated. And we have to just write this function. That's pretty simple now. See, we can write this function def, which is the helper, and I say n is int, which is index, which is the number at the green index. This is left, which is an int, and right is an int, and answer, which is a set of list of int. And what we were expecting that it should return the same, because this is the answer, which is working as an accumulator. It keep on populating each time, and we will return it finally here with the base condition. Now for this function, we say if our left is greater than equal to right, so I will just return our answer. In the else part, I will just go and do what we were doing here. So how we will do this is the same thing I'm going to do. So in this case, I will say sum is equal to n plus nums left plus nums right. Now in the next step, I will say if sum is equal to 0. This is exactly the same as we had before. If it is nums equal to 0, I will say helper. This function has to go and will for sure remain the same. And left, because we found the solution, left will move one step forward, right will go one step back, and in the list I will just add this new list, which is n nums left and nums right. That's the answer. This is a recursive call. We don't mutate anything. There is a mutation. There is a recursive call for that. In the else part, we will say else if sum is greater than 0. In that case, we will say go helper. And for helper, I will say n left. We are not going to move the left pointer because the sum is greater than our 0, and we have to move the right pointer, which is right minus 1. And answer will remain same because we never found any answer. In the else part, I will say helper, n remains same, left, go one step further, right will be there, and answer will be nothing. That's it. Pretty simple. Converting to functional code. So now, finally, I will just make it to list because this function is expecting a list of list, not set of list. So I will just run it. Let's see what is the answer. So it is working. Thanks. Hopefully it will help. Bye.